Happy Friday, Stats Gurus. I hope that you guys are doing well this morning. I wanted to just pop in really quickly, do a video for you guys because I think that there's still some confusion around the different levels of measurement. And I would not be a good professor if I allowed you to go into the weekend concerned about whether or not a variable is nominal or ordinal, interval, ratio, and that sort of thing. So I am here to kind of provide some comfort for you, to quell some fears and anxiety that you may have. So I really and truly hope that this video helps. And after you've watched the video, if you would like another opportunity to complete the quiz, please let me know and I'll reset that for you. As far as I'm concerned, my job is to ensure that you understand this information so that when you move on to the next phase of your program or the next stats class, you have what you need. So to me, it's not about a grade. It's really and truly helping you to understand these concepts so that you know what you're doing. You know, I know that there's some of you who are in PhD programs or who will eventually be in PhD programs, or you'll go on to take 701 and those sorts of things. So this course is really and truly the foundation of that. So it's important that you understand this information. So I did a very quick PowerPoint presentation that I'm going to pull up here in a minute. And again, even after reviewing this, if you still have questions, please reach out to me. All right, so let's get the screen share started here. All right, let's see what we can do. All right, there we go. All right, so again, just 9 slides here. It shouldn't take me really long to get through this information. So let's get started. All right. Let's see, there we go. As you guys know from reading the textbook, from looking at the video that was posted, that was created by Dr. Balkin, and maybe you've gone out and done some research on your own. And I truly hope that you're doing research on your own. You're not just, relying on one source or 2 sources. I know for me, when I was taking stats, as many sources as I could find without being overwhelmed or going down rabbit holes was something that I always did. I wanted to see another example. I wanted to understand another way of how something could be done, or even to get a different explanation of the same information. I think really helped me to better understand, some of the concepts that we're studying now and some of the things that you'll probably see a little bit later on. So again, I do hope you're doing Google searches. I do hope you're looking at other stats books. I do hope you're looking for other examples in terms of what these things are and what they should be and will be. Okay, so as you know, there are 4 levels of measurement. Those are nominal, ordinal, interval, and ratio. There's some other categories that were included in the discussion over this past week or so, and that's discrete and continuous. So I'll end with those 2. So let's dive into nominal data. So nominal data is simply named, and it's used only for classification. There's no specific order associated with this. And these type of data are generally collected by asking open-ended questions, like what's your ethnicity? Which brand of smartphone do you prefer? And because of its classification, or because of how these data are classified, that means that we really and truly can't do any calculations with them. We can't do a t-test. We can't do an ANOVA, an ANCOVA, multiple regression. Again, this information is only for classification labeling purposes. So again, gender, a lot of times when you're looking at research studies or you're doing your own data, we'll assign a number to gender, 1 for female or 1 for male, 2 for female. But again, that is only for labeling purposes. We can't run a t-test on gender, on male and female. So again, simply named, simply used for classification. We can't order it, so we can't say 1st, 2nd, 3rd, or 4th with numeral data. Okay, so we get there's some other examples. Where do you live? In the suburbs, in the city, in the town. I live way out in the county in Tennessee here. So again, simply named, used for classification. But again, this is data that's oftentimes collected by researchers. You know, a lot of times we want to know what the gender of our participants are. We want to know what their ethnicity is, because we can a little bit later on look at some different things. You know, we have other numbers, we have other types of data, and can kind of bring it back to, you know, to this nominal, these nominal classifications. Okay. So the next one here is ordinal. I'm sorry, data. It's still a little early for me. I'm not a morning person. So the second one is ordinal data. And this is data that can be classified just like nominal data, but it can also be ordered. So remember, this is going to be a theme throughout, you know, my brief presentation here, is that the further we move out along the scale, we'll see a repeat of those variables that fall before it. So again, if something is ordinal, it can also be nominal. So this depicts the order of variables, but still we don't understand what the specific differences are between those two variables. So I'll give you an example here in just a little bit. So in terms of high school graduation rankings, we can say, you know, there's a valedictorian. This is the person who graduates #1 in their class. There's the salutatorian. This is the person who's #2. You know, and then we have #3, 4, 5, and so on and so forth. So it can be ordered in that way. It's nominal in that we can classify, you know, this is the you know, top group of students who are graduating. This is a second group of students who are graduating, or we can classify it in terms of, again, valedictorian, salutatorian, and that sort of thing. But we really and truly don't know the differences between, you know, the individual who graduated 3rd in their class or the individual who graduated 4th in their class. Again, we can look at GPA as a way to determine class rankings, but really and truly, there's no specific measurement. There's no specific difference between those two that really and truly makes sense. Or we can look at, again, how satisfied are you with your cell phone? So it's ordered in that 1 is very satisfied, 2 is somewhat satisfied, and 3 is not satisfied at all. So it's nominal in that, I'm sorry, so it's ordinal in that sense, in that it can be ordered. It's nominal in that we can classify it as very satisfied, somewhat satisfied, or not satisfied. But again, we don't know the specific differences between what a person considers very satisfied and somewhat satisfied. Oftentimes this data, ordinal data, is very subjective, and it's coming from the individual's point of view, and where they may be very satisfied with their Apple phone, you know, in the morning, they could be very dissatisfied with it in the afternoon because they drop it or that it does something weird. So this is subjective. This is something that can change from point to point. Another example of ordinal data is levels of pain. If you go to the hospital, a lot of times, you know, the nurse will give you the smiley face scale and says, rank your pain. So again, this can be ordered in terms of, you know, a little pain versus a lot of pain. It's nominal in that we can classify it. So classify a little pain, classify medium pain, classify much pain. But again, we don't know the specific differences between a little pain, some pain, and a lot of pain, right? So it can be ordered, it can be labeled, but again, we cannot identify any specific differences between those levels that we're measuring. Okay? So the next type of data is interval data. So this data can be classified like nominal data. It can be ordered like ordinal data. And we can tell the difference between each of the variables. So if we remember with ordinal data, we had things like, subjective skills, like how do you feel? What do you like? And again, we can't measure specific differences between that type of data, but we can with interval data. And again, that's because we can identify these specific differences between those two things. There's a specific space. So because of that, we can move into using some more sophisticated statistical analyses. So we can run t-tests, we can run ANOVAs, we can measure central tendency, things like mean, median, and mode. So some examples of interval data include temperature. So 80 degrees is always higher than 50 degrees. And the difference between these two temperatures is the same as the difference between 70 degrees and 40 degrees, if that makes sense. So there's a 30-degree difference between 80 and 50. There's also a 30-degree difference between 70 and 40. And because we can specifically measure those, we know what each specific measure on that scale means, on the temperature scale means, we can say we can classify this as interval data. It's the same thing as time. The difference between 1 o'clock and 2 o'clock is the same as the difference between 2 o'clock and 3 o'clock. So if we're looking at 1 o'clock and 2 o'clock, a minute is a minute is a minute. You know, a minute is not going to be 60 seconds one time and 95 seconds the next time and 120 seconds the second time. A minute is always measured at 60 seconds. So again, because we know the specific space between each hour, this classifies as interval data. The same thing with temperature. Scores on an IQ test is another example of this. So again, this interval data is nominal. We can label it. We can do Fahrenheit or Celsius. It's ordered. There's a ranking. So we can, again, 70 degrees is hotter than 40 or 50 degrees. And again, we can differentiate the specific space between these two things or between these variables. Another thing to point out, though, is that with interval data, there is no true zero, which means that we can have negative numbers. And that particularly relates to temperature. So we can have negative 40 degrees or, negative 20 degrees and so on and so forth. Okay. So the next classification of data is ratio. So ratio includes all of the characteristics of the variables or levels of measurement before it. So it can be classified like nominal data. It can be placed in order like ordinal data. We can measure the specific differences like we did with interval data, but ratio data differs from interval data because we have an absolute zero. Remember, with interval data, there was no absolute zero, so we could have the negative temperatures. With ratio data, we don't have negative numbers, right? So there is an absolute zero. Some examples of that include age, and I have an asterisk by that, so it depends on how you're measuring that, how folks are looking at that. But we can have an absolute number in terms of weight. I can tell you that my weight is not an absolute zero. I'm kind of dealing with that right now, getting ready for a wedding. But height, ruler measurements, income, all of these examples have an absolute zero. So you can have no money in your bank account. You can have no years of education. Think about a 1 or 2 year old. You can have zero number of children, right? So this is what ratio data is. And so again, we can do some super fun, super sophisticated characteristics with ratio data as well. All right, so let's talk about the last two variables here, that's discrete and continuous. So discrete variables are obtained when you count. There are no values in between, and these are only whole numbers. So some examples of discrete data include the number of students present in the classroom. There's 7 of you guys. I can't have 6.5. I can't have, 4.35. These are always whole numbers. So the number of orange jelly beans in a jar, the number of heads that you get when you're flipping a coin. Money is another example of discrete data. The next type of data can be classified as continuous, and this is data whose value can be obtained by measuring. So with discrete, we count. With continuous, we're having to do some type of measurement in some way. Continuous data can take on any value, so we can have 2.5, we can have 5 feet 5 feet 2 inches kind of thing. So there's some in-between values that we can get with continuous data. So there's an infinite range of possibilities. So some examples of continuous data is height, weight, temperature, the time it takes to get to work. So it takes me approximately an hour and 15 minutes to get from Memphis to campus. And the distance travel, that's about 100, not quite 100 miles. I can't remember exactly, maybe 85 miles or so from my house to the campus there. So again, continuous data is obtained through measuring. And there's an infinite range of possibilities here. All right, so we're good, we're clear on that. The 4 levels of measurement, we have nominal, ordinal, interval, and ratio. If data is classified as ratio, it can also be classified as interval, ordinal, and nominal. If data is classified as interval, it can also be classified as ordinal and nominal, or it has those properties. If data is classified as ordinal, it also has nominal properties, so it can be classified. And if it's nominal, that's all it is. You're only labeling, you're only providing categories. All right, so a really quick quiz for you. I think I may have messed it up because I'm still trying to figure out this whole animation thing, but we'll see what we can do here. All right, so let's see. So the next slide here. All right, so yeah, I just gave you the answer there. So list all the variables for weight, right? So we talked about weight. We talked about weight as being, weight can be nominal. So we can classify weight as, lightweight, medium weight, heavyweight. So we're thinking about boxing and things like that. We can classify it in that way. Weight can also be ordinal. So again, there's an order to it. So, again, I'm using my thoughts here, some examples here. So it's ordered. So we know that 1 pound is less than 2 pounds, less than 3 pounds, and so on and so forth. Or even if we're looking at how we classified it as nominal data, lightweight is can be listed as number 1, where middleweight is number 2, heavyweight is number 3. So again, there's some order to that. Weight is also interval. Let me look here, make sure I'm seeing this right. So in terms of interval, we know that 1 pound is the same, the difference between 1 pound and 2 pounds is the same as the difference between 2 pounds and 3 pounds. So again, we can order this. We know that 3,600 calories equals a pound, and that's continuous. That happens from pound to pound to pound. So it's interval in that way. It's also ratio because we can have an absolute 0 in terms of weight. Weight is also continuous because there is an infinite range in terms of what a person can weigh. So weight is nominal because we can label it. It's ordinal because we can put it in order. Again, lightweight, medium weight, heavyweight. It's interval because we know the specific difference from pound to pound. And it's also ratio because there is an absolute 0, and it's continuous because, again, there's there is no end in terms of what a person can weigh, what a structure can weigh, and so on and so forth. All right. So what about temperature? Temperature is nominal, it's ordinal, it's interval, and it's continuous. So again, we can label temperature as Fahrenheit or Celsius. It's order because again, again, one degree, 2 degrees, so on and so forth. It's an interval because we know the specific difference between each measurement on the temperature scale. It's non-ratio, right? Because there is no absolute zero with temperature. We can have negative numbers, but it's also continuous because again, there's no end in terms of where temperature can go on the hot end or even the cold end. So I hope that this presentation helped. Again, watch it a few times if you need to. And if you have any questions, please, please, please shoot me an email, send me a text and let me know. And after viewing this, again, if you want to go back and take the quiz again, I can definitely reset it for you. That's not a problem. My job is to help you get through this class, and we only have 2 weeks left, guys. So I want to make sure you get it. I want to make sure that you understand it. So this is all that I have for you today. And I look forward to seeing you guys on Monday. So have a great weekend. Bye.